Alright, let's go back over graphing cubic functions. We're going to look at transformations today. So my base parent function of a cubic function, okay, is y equals x cubed. If I was to take negative 2, I'd plug it in. I would get negative 2 times negative 2 times negative 2. It's going to give me a positive 8. Negative 8, excuse me. So at negative 2, we have the point negative 2, negative 8. At negative 1, if I plug in negative 1 cubed is going to be a negative 1. So we have the point negative 1, negative 1. At 0, it's 0. At 1, it's positive 1. And at 2, it's positive 8. So my parent function of a cubic function is right there. Now this point 0, 0 is what I call my inflection point. It's where it changes concavity. So down, okay, concave down, to where it changes to concave up. Domain, we would say that's all real numbers. Range would be all real numbers, or from negative infinity to positive infinity. It is an odd function. Okay, what that means is that I was to plug in a negative value for x, I would get a negative value for x. So that's an odd function. My intercept is at 0, 0. It is an increasing function because as my x values increase, my graph is increasing. And my end behavior, as x approaches negative infinity, y approaches negative infinity, or f of x, I should say, sorry. And as x approaches positive infinity, f of x approaches positive infinity. Alright, so let's talk about some transformations to these cubic functions. Let's look at number 1. Alright, number 1, I can see right here I have two transformations, bam and bam. Right? So my base rule, okay, would be f of x equals a x minus h plus k. A is going to transform, h is going to transform, k is going to transform. And now understand that we can have a value for my coefficient in front of my x. Alright, so let's see what changed, right? So let's go through our points here. Alright, so let's make our list of values. Start with 0, 0. Start with 0. If I plug in 1/4 times 0, like 0, 0 cubed is 0, so 0, negative 3. So we know right now that my inflection point of 0, 0, we went down 3 units. So we can say a transformation down 3 units. Now what calls that transformation? This puppy right here. So this is up or down. Alright, now let's figure out what this 1/4 does. Alright, so if I was to plug in, let's say 4, I take 1/4 of 4, and that's going to give me 1. 1 cubed is still 1. Minus 3 is a negative 2. So if I go over 4, I'm going to go down 2. Bam, there is my point. If I was to plug in negative 4, that would give me a negative 1 inside, which negative 1 cubed is still negative 1. And then minus 3 is a negative 4. So at negative 4, we're at negative 4. Alright, so my graph looks like this. Okay, so this would be a horizontal stretch. By 4. Remember, when I'm a horizontal stretch, it's by 1 over b, which in this case is 1 over 1/4, which is positive 4. So a horizontal stretch. So we took this graph, okay, and we stretched it horizontally. Horizontal stretch. Notice that is inside of my parentheses. So this is a horizontal stretch or compression. So let's look at the difference in number 2. Okay, number 2, we can see that the 2 is not connected with the x. The 2 is outside of those parentheses. We also have this puppy, and we also have that little thing. Alright, so this transformation is inside of my parentheses. This one was not. This one moved up or down. This one's going to move right or left. This number is outside of my parentheses, not connected with my x. This was what? This was, excuse me. So this was a horizontal stretch or compression. This is a vertical stretch or compression. And then this negative is, just like we always do, would be to flip it. Alright, so now we can look just from our inflection point at 0, 0. We know that we're going to move to the left because it's opposite, to the left 1 unit. So we know we should have a point at 0, negative 1. If I plug in 0, I get 0, positive 1, 1 cubed. Sorry, if I plug in 0, I get positive 1, 1 cubed is 1, times 2 is 2, negative 2. Alright, so again, this is going to move it right or left, so if we're moving it left, because we're opposite here, we take my inflection point and move it left 1, this would be a negative 1 in place of x. So negative 1 plus 1 is going to give me 0, 0 times 2 is still 0, 0 cubed is 0, negative 0, whatever. Alright, now if I plug in 0, okay, I've got 0 plus 1, that's going to give me 1. That's going to be times 2, so 1 times 2 is 2. We cube that's 8, negative 8. So we have a point at 0, negative 8. If we plug in negative 2, negative 2 plus 1 is going to give me a negative 1 here, times 2 is a negative 2. We cube that, that's a negative 8. A negative negative 8 is a positive 8. So at negative 2, we're at positive 8. So you can see how the graph flipped, and now we're opening the other way, right? So instead of us being an increasing function, this is now a decreasing function. Alright, so let's talk about our transformations. Okay, we know we flipped. We know we had a vertical stretch. We know we had a shift, horizontal. Translation. Left 1 unit, because again, if it's inside the parentheses, it's always opposite. Alright, let's keep going. Let's look at number 3. Alright, number 3, I have 1 transformation, 2 transformations, 3 transformations, 4 transformations. Right, so now once again, this is not connected with the x, so this would be a vertical compression. This is inside of my parentheses, so that's a horizontal translation. And it's going to be plus, so it's left 2. This is an up 2. And this is a flip. Alright, so those will be your transformations. Alright, so let's take our original inflection point of 0, 0. We know we're going to translate it left 2 units and up 2 units. So our new point is going to be at negative 2, positive 2. Now, for my parent function, if this was at 0, 0, let's go back to our parent function. Okay, this is at 0, 0. We have another point that is 1 unit away and 1 unit up. Alright, so this, we know we have a vertical compression. So instead of it going 1 unit up, 1 unit over, we would go 1 unit up, 3 units over. But now it's flipped, right? So instead of going up 1 unit and right 3, we're going to go down 1 unit and right 3. Same thing, I have another point on the other side of it. Okay, so this would be, instead of going up 1 over 1, we would go up 1 over 3. So my graph would look like this. Let's talk about our transformations, right? We had a flip. We had a vertical compression by 1/3. We had a translation, left 2, and we went up 2 units. Alright, last one, let's look at number 4. We know we have a transformation here, transformation there, transformation there. Alright, so let's talk about what changed on the graph. Alright, let's take our original point. Inflection point is at 0, 0. Okay, we know that we're going to move it right 2 units because it's inside the parentheses. So we're going opposite of what it says. So my new inflection point will be at 2, 0. So we know we can start our table of values. Let's look at 1, which is on the left side of this. If I plug in 1, 1 minus 2 is a negative 1. Times a negative 1/2, that's going to give me a positive 1/2. 1/2 cubed is now 1/8, and then times 3 is going to give me 3/8. Okay, or we could say about 0.375. So at 1 we've got 3/8 or 0.375. If I plug in 3, so on the other side of my inflection point, 3 minus 2 is a positive 1. So now we have positive 1 times negative 1/2. That's a negative 1/2. When we cube it, we get a negative 1/8. And then times it by 3 again, and we get negative 3/8. So negative 0.375. If I plug in 0, 0 minus 2 is a negative 2. Times a negative 1/2, that gives me a positive 1. 1 cubed is 1 times 3, so at 0 we would have 0.3. Didn't graph that right. That means at 4, okay, if we plug in 4, 4 minus 2 is a positive 2, times a negative 1/2 is a negative 2. Sorry, positive 2 times negative 1/2 is a negative 1. Cubed, we get a negative 1 times negative 3, which would be a negative 3. So my graph looks like this. Alright, so what transformations took place? Obviously we flipped. We had a vertical stretch. By 3. We had a horizontal stretch by 2. And then we had a translation right 2.